Bismillahirrahmanirrahim. Welcome guys, my name is Azan Ahmed and by profession I am a civil engineering student. So in this tutorial I am going to teach you the mixed design of conventional concrete. So what do we mean by conventional concrete? First of all, conventional concrete is the normal type of concrete in which we basically use cement, coarse aggregate, fine aggregate and water. And if we alter the proportions or we alter the material, then the concrete is no more called as the conventional concrete. For example, you may use polyvinyl alcohol, or you may use glass fiber or cotton fiber, or you may use the coconut hair fiber. So this kind of concrete are then no more called conventional concretes. So in this lecture basically we will be seeing the concrete, which will be normal concrete and its mixed design. So you already know what is concrete, the conventional concrete. Now what does we mean by mixed design of concrete? So mixed design is actually the process of selecting the different ingredients that we use in concrete, that is cement, coarse aggregate, fine aggregate, and the water, to know the amount of each ingredient, to know the quantity of each ingredient that we need to put together to make a concrete of desired strength, workability, durability and economy. For example, you want to achieve a concrete of 3000 compressive strength. So what do you need to do? You need to do the mix design of that concrete. Similarly, workability, which is basically tells you about how workable, how easily you can handle a concrete on a site. So in terms of slump, you measure the workability and durability, that when you made a concrete, so during its design period, it should not deteriorate. So to achieve such kind of concrete we need the mix design. Similarly, economy, that your concrete shouldn't be so much expensive, but it should be cheap as much as possible. So to achieve such kind of mix or concrete, we need to study the mix design. Now, in order to make a mixer, you have certain options. Either you can use this first technique, standard mix technique, nominal mix technique, or design mix technique. Now what does we do in standard mix technique? We use a standard ratio of 1 ratio 2 ratio 3, where this first digit stands for cement, the second stands for fine aggregate, and the third one stands for coarse aggregate. So if you are following this ratio, then this kind of mix is known as standard mix. And we make the standard mix when we have very unimportant project, like if you are working, if you are repairing some wall in your home, or we are doing some kind of work which is very unimportant. So we prepare this kind of concrete usually, and this is standard mix. We do not this prepare this kind of mix for important projects like construction sites. So we are working on a slab, then we do not prepare this kind of mix, but we can prepare this nominal mix. So what does we do in nominal mix? In nominal mix, we obtain the values or the proportions from a code. Different codes have suggested that you should use this ratio in order to achieve the concrete of this much strength. For example, you want to achieve the concrete of 3000 psi, then different codes recommend you that you should use the ratio 1, ratio 1.5, ratio 3. But this may not be giving you the 3000, it may give you 1800. That's why in order to achieve the exactly certain psi strength, pressure strength, and workability and economy and durability, we need to go for the design mix. So design mix is very detailed procedure of finalizing your proportion. So we follow the procedure suggested by code to obtain the concrete of desired strength and workability. So either you can make your own standard, or you can follow a code to obtain the ratio for your desired strength and workability. And it is done for very important projects like shear wall, retaining wall. So for that kind of projects we follow this mixed design technique. and we have different codes for that. For example, ACI 211 291 for normal concrete mix designing. Similarly, there is another code of Indian standard which is 10262 2009 for normal concrete mix designing. So now the necessary data that we need in order to design a concrete according to ACI 211. I will be basically discussing this ACI 211. I will not be discussing the Indian standard. So you need compressive strength. How much compressive strength do you need to achieve? What is the requirement of workability? How much slump do you require on a site? What is the water to cement ratio? And maximum size of aggregate, which comes from the sieve analysis. Similarly, you need to know the dry eroded density of coarse aggregate. You need to know the fineness modulus of your fine aggregate, water absorption, free moisture content of coarse aggregate and fine aggregate. This all comes from the test in a laboratory. We'll need to know the specific gravity of coarse aggregate, fine aggregate and cement. We need to know the cement type and strength. So the general steps are to first of all choose what is the required slump. So if you don't know the required slump, then the slump is recommended in the table 6.3.1 of ACI, and it depends upon the type of construction and as well as the weather conditions. Determine the maximum size of coarse aggregate. So you should determine the maximum size that you have coarse aggregate sample, but what is the maximum size of aggregate that is available on the site? So you should know that maximum size of coarse aggregate, which could be in inches or in millimeter. Similarly, you need to know you need to approximate the amount of water actually in pound per cubic yard and air content. So this depends upon the slump and maximum size of coarse aggregate. Air entrainment depends upon the exposure condition. Table 6.3.3 should be used to obtain the value. So water content and air content basically depends upon the slump, maximum size and exposure condition. So if you have a sample of coarse aggregate which contains very small coarse aggregate, and there is another sample which contains bigger particles, so obviously the bigger particles will require less water in order to lubricate the coarse aggregate, but this finer coarse aggregate will require more water. So that's why water content depends upon the maximum size. Similarly, slump, you require more slump, then you should have to use more water. And similarly, the exposure condition, if the exposure condition is such that it is too hot, then you need to put more water in order to achieve the required slump. So if you don't know the amount of water to be used, so you can use this table, and you should approximate the water to cement ratio. For this you should use 6.3.4 of the ACI to 11, estimate amount of cement content. Then once you know the water to cement ratio and water content, you can estimate the amount of cement content, because water to cement ratio would be, for example, x. Then you know water content, so cement ratio can be cement content can be easily found out. Another thing you need to know is the amount of coarse aggregate in pound per cubic yard, and this is basically equal to dry eroded density. Now what is dry eroded density? Let me give you a little hint that if you have aggregate, you just compact those aggregate, make it dry, and just find its density, which is mass per unit volume, and then you multiply this value with a value obtained from table 6.3.6 and multiply it with 27, because the dry eroded density will be in pound per cubic feet. So if you multiply it with 27, you will get the amount of coarse aggregate in pound per cubic yard. So basically we are dealing with the yard unit in this ACI 211. So table 6.3.6 contain the volume of coarse aggregate per unit volume of concrete, which required maximum size of aggregate and fineness modulus. So you need to know fineness modulus of fine aggregate and maximum size of aggregate in order to obtain that value, which you will be using in this formula basically. And then you should estimate the amount of fine aggregate. The amount of fine aggregate could be in terms of weight, or it could be in terms of volume. So let's say we are estimating in terms of weight. So you need to know the weight of fresh concrete, for which you should use table 6.3.7.1. You can also estimate it like the specific weight of concrete is 149. So if you multiply 149 with 27, you will get the weight of fresh concrete in pound per cubic yard. So you have already known the weight of coarse aggregate from step number 6, weight of water from step number mm, 3, and weight of cement from step number 5. So you can estimate the amount of fine aggregate. So you have known all the quantities, their weights. Now if you are using the volume basis method, then you should also know the amount of air, because air would also occupy some space. So you should also subtract the amount of air if you want to know the volume of fine aggregate. And once you are known with these values, now you should do adjustment for aggregate moisture. Then for that you should do adjustment for aggregate moisture, and then finally trial and error and re-estimation. So you should check the workability, whether whether the finalized proportion is giving you the required workability or not, and if the compressive strength is not according to the required value, then you should to do trial and error and re-estimate. Now we will be solving this example 1 on mixed design of conventional concrete. I have taken this example from this paper ACI 211 1291. It says that type 1 non-air entraining cement. So the concrete is non-air entrained concrete. So this cement will be used with specific gravity of 3.15. This has came from test. The coarse aggregate has a bulk specific gravity of 2.68. So they have given that the coarse aggregate has the specific gravity of 2.68 and an absorption of 0.5%. So the coarse aggregate absorb 0.5% of the water. And they have also given that the fine aggregate has a bulk specific gravity of 2.64 and an absorption of 0.7% and fineness modulus of 2.8. So these all the data are given. Other requirements are that the concrete should be 3500 psi, slump should be 3 to 4 inches, minimum is 3 and maximum is 4. Dry road density of course aggregate is 100 lb per cubic feet. Aggregate graded from number 4 to half inch aggregate will be suitable. So they have passed the aggregate from 1.5 inch to the sieve which have 4 holes. So it means that the maximum size of aggregate is 1.5 inches, and they have also given that the aggregate is not exposed to severe weathering and sulfate attack. So first step is to choose the slump. So it is already given that the slump is 3 to 4 inches. So the second step, which was to know the maximum size of aggregate. So maximum size of aggregate is 1.5 inch. So this has came from a sieve analysis. And the third step is amount of water. So you can estimate the amount of water from a table which I will be showing you in a minute. So amount of water is equal to 300 pound per cubic yard with estimated 1% entrapped air. Now this entrapped air will be useful if you are following the volume basis method, but if you are not following the volume basis method, then it may not be of use. So this table is giving the amount of water. So it contains two portions. The top portion is for the non-air entrant concrete, whereas the bottom portion is for the air entrant concrete. As we are dealing with the non-air entrant concrete, so we will be using this top portion. So the maximum size of your aggregate is 1.5 inch and the slump required is 3 to 4. So you can see that the amount of water required is 300 pound per cubic yard, and you need to consider 1% air entrainment as well according to the ACI committee report. So these all I have shown over here. Now coming towards the fourth step. So fourth step is to estimate the water to cement ratio. So for 3500 psi, we have actually a table in which we have compressive strength and type of concrete, non-air entrant concrete and air entrant concrete. So your compressive strength is 3500. Just go there and search if 3500 is available. As you can see, there is no 3500 psi strength available. So what we can do, we can simply interpolate. So interpolation technique is very simple. Just by picking a calculator, and you can find that the by interpolating for non-air entrant concrete, the water to cement ratio comes out to be 0.62. Now the fifth step is to estimate the cement content from the water to cement ratio. It is very simple. You have water to cement ratio equal to 0.62, so just bring 0.62 down with the W, so you will get the value of C, which is basically the cement content in pound per cubic yard. So it is 484 pound per cubic yard. And the sixth step is to estimate the quantity of coarse aggregate. So the quantity of coarse aggregate is found out by this formula: radial density multiplied by value obtained from this table and multiplied it by 27. This table contains the fineness modulus of fine aggregate and the maximum size of coarse aggregate. So maximum size of coarse aggregate is 1.5, fineness modulus is 2.80. So the value which we will obtain from this table is 0.71. So just multiply these values with the 27 to obtain the value in pound per cubic yard. Now finally, the last quantity that we need to determine is the weight per unit volume of fine aggregate, or the weight of fine aggregate per cubic yard. So we need to know the weight of concrete. So weight of concrete can be estimated from this table either, or you can use the simple relation, that is 149, which is the specific weight of concrete multiplied by 27 to obtain the value in pound per cubic yard. But we will be taking the value from this table. So for half inch, the value comes out to be 4070. So 4070, and then these values are subtracted from the weight of fresh concrete, weight of cement, weight of water, and weight of coarse aggregate, which comes out from these previous steps. So you can see, so the value which comes out is 1369 pound per cubic yard. So this is the weight of fine aggregate. Now initially it is given that the coarse aggregate contains 2% of total moisture, fine aggregate contains 6% of total moisture. So it means that the weight which you have initially found is it is not the corrected weight, so we need to correct that. So we need to find the wet weight which we should use, because you will be having the aggregate on site which will be wet, so you will be using the wet weight. So either you should use the dry weight, for which you will be subtracting the total moisture, or you should use the wet weight. But you have the wet aggregates, so you should use the wet weights. So fine aggregate is the wet weight of fine aggregate is found out by adding 2% of by adding 6% of moisture, or 6% of the total weight of fine aggregate with the weight of the fine aggregate. So the wet weight comes out to be 1955 pounds, and similarly for the coarse aggregate it comes out to be 1451. Now you also need to reduce the amount of water, because the aggregate it's wet itself, so it contains extra water, so you need to subtract some amount of water. Now the absorption of coarse aggregate was zero point 0.5, so you need to subtract 0.5 from 2%, so it comes out to be 1.5. And similarly the absorption of fine aggregate was 0.75, so you need to subtract 0.75 from 6%, so it comes out to be 5.2%. Add these together and subtract this value from the amount of actual water. So the actual water you need to add is 199 lbs. Therefore per cubic yard values for water to be added is 199 lbs, cement to be added is 484 lbs, coarse aggregate wet weight is 1955 lb, fine aggregate wet weight is 1451 lbs. Now the last step was to perform the trial and error procedure. So for laboratory purpose it was convenient that we should use zero point zero 0.03 cubic yard. Now it is given in the example that we need 0.03 cubic yard concrete. So what we can do, we just multiply these values with this 0.03, so we get these values for water, cement, coarse aggregate, fine aggregate. But the value which we will be obtaining by multiplying 0.03 with 199, it would be 5, but they have used it 7 because they want to achieve the required workability. So that's why you can increase the value up to 2 or 3 or 4 lbs. So they have increased it by 2 lbs actually. Then you should also add this value will be useful if there is some error in the workability. So Now they have measured that the workability in terms of slump was 2 inches, which is not correct because the required workability was 3 to 4 inches, so we need to do adjustments. Now the specific weight of concrete was 149. Just divide this 123.70 by 149 pound per cubic feet, you will get this value. Now this value and this upcoming value, which is 7 plus 0.8 plus 0.86 plus 2.18, 2.18 and 0.86 are recommended by ACI. Now where this 7 digit comes from? So it comes from our here, the water to be added. So we are now going towards the finding the actual amount of water that we need to add in order to achieve the desired workability. So just divide this 10.04 by this 0.830 and also multiply it with 27, so you will get the amount of water. But the ACI says that this will again give you the 2 inches slump. So now what to do? So they say that if you are increasing the slump by 1 inch, then you should increase the water content by 15 lbs. So if you increase this by 15 lb, then it is giving you the value of 342 pound per cubic yard. And similarly the cement content will also need to increase, because we want to keep the ratio of water to cement the same, because we want to achieve the same strength, 3500 psi. So this is kept the same, and then this cement content has also got changed. Now we need also to adjust the amount of coarse aggregate. So amount of coarse aggregate is adjusted. Multiply this 58.65, which comes out from over here, with 27, and divide it with by 0.830, which comes out from here. So you will get this value of 1908, which will be the wet weight. Now sometimes you also need dry weight. You can also use this wet weight, but you can also use this dry weight. So now what to do? So 1908, you can subtract 2%, which is basically the total moisture in the coarse aggregate, or you can divide it by 1.02 simply, so you will get the dry weight. Similarly, in order to obtain the saturated surface dry weight, you need to add 0.5% of 1871 with this 1871, or simply multiply 1871 with this value 1.005. You will get the saturated surface dry weight. Now if you want to estimate the amount of fine aggregate, so amount of fine aggregate could be estimated by subtracting the weight of water, weight of cement, and weight of coarse aggregate from the weight of concrete. So weight of concrete is 149 multiplied by 27. 149 is the specific weight, and 27 is multiplied because we want to convert the value from pound per cubic feet to pound per cubic yard. So we got this value. So this value is obtained, then this is the saturated surface dry weight of fine aggregate. We need to convert it into dry weight, because this time we will be dealing with the values in dry condition. So just divide it by 1.007, because 0.75 is the water absorption of fine aggregate. So you will get this value of 1240 pound per cubic yard. The adjusted basic weight of concrete are, now you have adjusted the basic weight, so you can multiply these value with any of the volume that you required. So you will get the quantities that you need to have to make a concrete of desired workability, strength, and durability and economy, and all those factors. So the water content that we need for mixing per cubic yard is 342, and for 0.76 cubic meter is 155. Now if you want to obtain the value for 0 0.5 cubic meter, then simply multiply this 155 with 0.5, so you will get the amount of water for 0 0.5 cubic meter. Similarly for the cement, coarse aggregate, and fine aggregate, you can also estimate the volume of water if you want. So just divide the weight of each ingredient divided by the specific gravity multiplied by the specific weight of water, so you will get the volume of each ingredient. like for example for cement the weight per cubic yard was 522. So if you divide it by 3.15, which is the specific gravity of cement which was given in the question, and the specific weight of water, which is the specific weight of water, so you will get the amount, the volume of cement. Similarly for coarse aggregate, and similarly for the fine aggregate. Now if you want to achieve the proportions, so you can divide the volume of cement, volume of fine aggregate, and volume of coarse aggregate by the volume of cement. So if you divide all these values by volume of cement, so you will get the ratio. So if you divide 2.644 by 2.644, you will get 1. So if you divide 11.18 by 2.644, so you will get 4.22. And if you divide 7.52 by 2.644, so you will get 2.84. So this way you can obtain the proportions of different ingredients. And similarly you should also prepare concrete cylinders of 12 by 6 inches, and you should test the compressive strength of your concrete after 28 days. So if the strength of the concrete is according to the desired values, then you should use this proportion. Otherwise you should change the water to cement ratio. I mean you should decrease that, because if you are getting less compressive strength, then you should decrease the water to cement ratio, because water to cement ratio, if we see the relation of water to cement ratio, then it has an inverse relation with the concrete. So you should decrease the water to cement ratio in order to increase the amount of cement. So increasing the amount of cement will lead towards the increase in compressive strength. So this way you can perform the trial and error procedure. Thank you.